Hello, this is Think Big Online Education, Senior 4 Mathematics for Combination, Unit 1, Fundamentals of Trigonometry, Lesson 1, Trigonometric Concepts, presented by Tita Ruiz. We start from a point of trigonometric concepts and definition of trigonometry. What is trigonometry? A trigonometry is derived from two Greek words. Trigon, which means triangles, and metric, which means measure. Trigonometry is the study of how the sides and angles of a triangle are related to each other. Means, in one word, a trigonometry is a study of angles and sides of triangle. Another definition is definition of angles. Angles are named according to where their terminal side lies. The x-axis and y-axis divide a plane into 4 quadrants as follows. The cycle is divided into two, can be presented in two directions. You have first direction. It is a positive direction called the positive direction. Then another direction is called the negative direction. The first one, it is the anti-clockwise direction. This direction is called anti-clockwise. The negative direction is the clockwise direction. We have first quadrant from 0 to 90 degrees. From 90 degrees to 180 degrees, we have second quadrant. Third quadrant is from 180 degrees to 270 degrees. Then fourth quadrant is located in interval for angles 270 degrees to 360. A rotational angle is formed by a initial side. This is initial side. This is a initial side through angle about a fixed point called a vertex. This point, a fixed point, is called a vertex. This is a vertex. To determine a position called the terminal side, this position is called the terminal side. A position of an angle. Position of an angle is called the terminal side. Angle is tangent positive that have a common terminal side are called an angle is standard position. In standard position that have a common terminal side is called contaminant angles. Means contaminant angles is many angles which can meet you on one point. They have common point. Means one angle is, for example, 54 angles in this one. Then another angle can be make rotation and then meet the first terminal in the same point, and then you can make with many angles which can somehow have the same common, or which can have the same terminal side on the same point. Those angles will be called contaminant angles. We have example number 2. Draw each of the following angles in standard position. and which of these angles is coterminal to 30 degrees. Standard position, it is a position from 0 to 360 degrees when we consider a cycle. From first quadrant to fourth quadrant, this position is what we call standard position. We have 30 degrees, 120 degrees, negative 230 degrees, then 750 degrees and negative 330 degrees. We have to present all of those angles and then show which are the coterminal angles with respect to 30 degrees. Then presentation of 30 degrees is represented as here. You see here you have 30 degrees. This is 30 degrees is located in first quadrant. This is first quadrant, this is second quadrant, this is third quadrant and the fourth quadrant. Then when we represent angle of 120, that angle is located between 90 degrees to 180 degrees, means 120 degrees is located in second quadrant. So this one is different from this. This angle is not coterminal with respect to an angle of 30 degrees because they haven't the common position. We have an angle of negative 230 degrees. It is in negative direction. When we draw these angles in negative direction, in this direction, means it will locate in second quadrant. From this one to this, you have negative 90 degrees. From this point to this point, you have negative 180 degrees. Then from 180 degrees to this point, you have negative 230 degrees. So when we draw an angle, we have this is the terminal arm. This is the line. The one is called terminal arm. This one as this. So an angle of 750 it is greater than an angle of a cycle. A cycle has total angle of 360. So when we have 700, you have first turn of 360 and the second turn of another 360 degrees. When we add two turns of this degree, we get 620, and then when we add 30 degrees, we will get 720. When we add 30 degrees to 720, we get 750 degrees. So this one is an angle is in the same position with respect to an angle of 30 degrees. From the origin to this point, you have an angle of 30 degrees because from two turns, we have two turns of cycle, means 720, and then we add 30, we get 750. We have another point of angle of negative 330. Also, we have in negative direction. Here we have negative 90, negative 118, then negative here 270, then from 270 to this point is 330 degrees. It is in the same position with respect to 30 degrees. As conclusion, 750 degrees and negative 330 degrees are coterminal with respect to 30 degrees. Means after those point and the example, everyone can also repeat and calculate and calculate the same or similar example with respect to this one. We have such examples. Draw each of the following angle in standard position and indicate in which quadrant the terminal side is. So we draw the position of those angles and then precise the quadrant where those angles are located. Then first angle, it is angle of 150 degrees. When we use a protractor, we will find the position of this angle is in second quadrant. This is second quadrant, because here you have 90 degrees, here you have 180 degrees. So this position is 150 degrees. Second one, we have negative 35. Negative 35, we draw our angle in negative direction. It is located in the fourth quadrant. This is the fourth quadrant. Then 210 from the origin of 0. Here you have 90 degrees, 180 degrees. Then our angle is located in a third quadrant. 210 degrees is located in fourth quadrant, or rise in the third quadrant. This is third quadrant. We meet with a point of measure of an angle. We measure of an angle with using many systems. We start from system of sexagesimal system. In the sexagesimal system, we use unit of degrees. A degree is unit of angle in the sexagesimal system. Degree is represented by a power of O. We write a number and then we put power of O. As here you see, this is 1 degree. We have a power of O. A 1/90 of the right angle means 1 degree. 1 degree is corresponded to 1/90 degrees. When we make first quadrant from 0 to 90 degrees, its length, you divide it with 90 subdivision. So 1 subdivision is corresponded to 1 degree. In angular measure, the degree is subdivided into minutes. 1 degree is corresponded to 60 minutes. 1 minute is corresponded to 60 seconds. Example number 4. The angle which measure 12 degrees, 35 minutes, and 50 seconds can be written as here you see. Is written 12 degrees, 35 minutes, and 15 seconds. Here we have a point of degree, minutes, and second. It is somehow we can change degree, minute, second into decimal degree and vice versa. D represent the integer part of degree, integer part or integer of degree. DD represent the integer part of decimal degree. M represent minutes and S represent second. Then we can write D is integer of decimal degree. M represent integer of this operation. When we take decimal degree negative, integer degree times 60. Second can be calculated by dd decimal degree negative integer degree negative minutes over 60 times 360 3600. For an angle with integer degree m minutes and s second, right, and as here you see, the decimal degree dd can be calculated as here you see. Then when you are asked to translate from integer degree, minutes and second into decimal degree, you have degree plus minutes over 60 plus second over 3600. Example, we can convert 30.26388889 degrees to degree, minutes and second system. From this relation, we start from calculating the degree integer. D is the degree integer. Degree integer is the integer which is different from we consider the number before a point here. We will consider the number before a point 30 only, 30 degrees. So we will get 30. We take only the number which is before a point. Minute is integer. By using this relation, we take decimal degree. You know, decimal degree is this one. Decimal degree is this. We subtract d. Integer degree is 30. Then we multiply 60. So after calculating this one, we will get the value of 50 degrees. We take integer only. We can find more 50 something and so on. So we will consider integer part of this operation. We take integer part of this operation. To find the value of second, we take dd, decimal degree, we subtract decimal degree is this one, we subtract integer degree, which is equal to 30 degrees, then subtract minutes is found 50 minutes over 60, then we multiply this one by 3600 finally after making some operations, and then we get 50 seconds. Then to write an answer, we can write this decimal degree into degree, minutes and second. This one is equal to this after making some operation and calculation. We have example number 6. We can convert this example 30 degrees, 50 minutes and 15 minutes and 50 seconds angles to decimal degree. We can use the following formula. This one and this can be replaced in decimal formula. We'll use this decimal degree formula. We take d is 30 degrees. We add minutes over 60. Minute is 15 over 60. Then plus second is 50 over 3600. Then after making the operation, we get the value of 30.263 and so on degrees. We take another unit of degree. In a centesimal system, we have a grade. One grade is equal to 1 over 100 of the right angle, and is its subdivision. We take the length from 0 to 90 degrees, or right angle, we divide it by 100. We get one subdivision is corresponded to one grade. So subdivision of grade is decimal grade. Decigrade is equal to 1 over 10 grades. Centigrade is equal to 1 over 100 grades, and milligrade is responded to 1 over 1000 grades. We have example. An angle which measure 82 grades, 7 decigrade, 2 centigrade, and 5 milligrade will be noted by 82 grade, 725 means 725. This one can be written representing as 82 grade, 7 decigrade, 2 centigrade, and 5 milligrades. We have another unit called radian. So we consider radian when we refer from a cycle. This is a cycle. A cycle has radius. We can measure the length of this radius, which is corresponded to the arc. This arc, the length of arc. This is the length of arc. When the length of this arc is equal to radius, the angle which is corresponded to this length, to the point of length, is called it is corresponded to 1 radian. Means 1 radian. When we measure the length of radius here, then we put it on this side. The point of this side, which is equal to radius, it is corresponded to 1 radian. When a central angle intercepts an arc, means a central angle is intercept an arc. This is the arc of cycle. It intercept an arc that has the same length as a radius of the cycle, means the length of here is the same as the length of arc. This corresponded the angle is equal to 1 radian. Like degree, radian measure the amount of the rotation from the initial side to the terminal side of an angle. We have seen as when we draw this one in a quadrant, this is called a terminal side, position of angle. Proportion between 3 units. We know 2 pi. It is a measure of in radian of all cycle. Means cycle in 4 quadrants is corresponded to 2 pi, or as it is corresponded to 360 degrees. Means 1 pi is corresponded to 180 degrees. 360 degrees is corresponded to 400 grade, as 180 degrees is corresponded to 200 grades. So when you combine all 3 unities, can be written as a degree over 180 is equal to radian. R represent radian over pi equal to grade over 200. When we make subdivision of all 3 relations, element of relation can be written as d over 180 is equal to r over pi, or d over 180 is equal to grade over 200, and r over pi is equal to grade over 200. We have example. Convert 90 degrees to radian and grade. We know it is right angle is known. When we use first relation, we replace degree, its value 90 degrees. We remain to find the value of radian. We make a cross product and then we find the value of r. r is equal to 90 times pi over 180. We know the value of pi is equal to 3.14. 3.14, when we divide 3.14 over 2, we will get radian, which is equal to 1.57. Then in the grade, we have value of degree. We replace degree its value. Then we remain to find the value of grade. We make operation, and then we remain with the value of grade. Grade is equal to 90 times 90 times 200 over 180 means is equal to 100. 90 degrees is corresponding to pi over 2, as there you see. And the 90 degrees is corresponding to 90 degrees. This one is corresponding to 100 grade after calculation. We have a second 9th example, which is to convert to 20 grades to radian and degree. Also, we use the relationship formula relating grade to radian and grade to degree. Means this is relation relating grade and radian. Then by replacing grade its value, we make operation here. We make cross product, and then calculate the value of r. So after calculation, we get pi over 10. You know the value of pi is 3.14. When we divide 3.14 by 10, we get 0.314. To find the value of degree, we replace grade its value, which is equal to 20. Then after making operation, we get grade is equal to 18. Then as a conclusion for this point, 20 grade is corresponding to 18 degrees, and 20 grade is corresponding to pi over 10 radian after calculation. We have a unity cycle. What is unity cycle? A unity cycle is a cycle which has a central 0, 0 and the radius equal to 1. From central to a curve of function, a curve of cycle is equal to 1. You have this distance equal to 1. This one also is equal to 1. It is one in negative direction also is equal to 1 negative direction. So we can consider clockwise, and this direction is clockwise. This one is anti-clockwise direction. We have a trigonometric ratio of acute angle. Trigonometric ratio. What is trigonometric ratio? A trigonometric ratio, it is we have 6 trigonometric ratios. The first one is 3 primary, the second one is 3 reciprocal. In a primary ratio or trigonometric values, it is cosine, sine and tangent. It is the first one. The first one is cosine, second one is sine, third one is tangent. But the second reciprocal trigonometric values is the secant, cosecant and cotangent. So from this relation of cycle, in a cycle you have a triangle of angle alpha. Let's consider the value of alpha here. This is adjacent side with respect to alpha. This is opposite side with respect to alpha. This is hypotenuse side with respect to this alpha. Here you have right angle of 90 degrees. So let's start finding the value or formula of those trigonometric value. We start from primary trigonometric value. The ratio of x over r, the ratio of x over r, it is adjacent side over hypotenuse, is called the cosine of alpha. Its symbol equals alpha. When we take y over r, this is opposite side over hypotenuse side, means over radius. It is called sine. Each symbol is denoted by sine alpha. When we calculate the ratio of opposite side over adjacent side, y over x, this one is called tangent of an angle alpha. Then we take three reciprocal trigonometric value. It is the inverse of the primary trigonometric value. When we inverse cosine, for example, we will get r over x. When we inverse this one, we will get r over y. When we inverse this one, we will get x over y. It is simple. This one is secant as the inverse of cosine. As here you see, inverse of this one. This one is cosecant. It is inverse of sine. When we inverse this one, we get r over y, as here you see. When we inverse the value of a tangent, we will get x over y as the cotangent or inverse of tangent. As you have said, this one, sine is opposite side over hypotenuse. Cosine is the adjacent side over hypotenuse. Tangent is the opposite side over adjacent. Secant is equal to hypotenuse over opposite. This is opposite. This is opposite side with respect to alpha. This is adjacent side with respect to this alpha. This is hypotenuse side, as here is somehow calculated. Cosine, when we consider a unity cycle here, the cycle of radius 1. When the cycle has radius 1, we can somehow find the adjacent side. Cosine is equal to adjacent side, as here you see. Cosine is equal to adjacent side, and the sine is equal to adjacent side. Because when we divide this one by 1, we remain with the value of adjacent. When we divide this one with 1, we remain with also opposite side, because the radius is equal to 1. Tangent is opposite side over adjacent side, or the length of y coordinate over x coordinate. As here you have y coordinate, this is x coordinate, this is y coordinate, or y coordinate, this value y coordinate, then this is x coordinate. Next, we have example number 10. Calculate the 6-side trigonometric value for the diagram. 6 trigonometric values are cosine, sine, tangent, cotangent, you have cosecant, you have secant. To calculate each value from, for example, sine of theta, sine of this angle is equal to, sine is equal to opposite side is equal to 4 over hypotenuse side. In place of cosine is equal cosine of theta. Cosine is adjacent side over hypotenuse side. Then the tangent is equal to opposite side over adjacent side. Cosecant here is the inverse of sine. We inverse this value. We inverse this value. Then the secant is the inverse of cosine. We inverse this one. It is 5 over 3. Then cotangent, we inverse the value of tangent. Example number 11. For each angle, calculate reciprocal trigonometric value, means cosecant, secant, and cotangent. For each angles, the angle for A, angle for C, and the angle for B. Angle for A, we have cosecant is inverse of sine, or hypotenuse over opposite side, means hypotenuse is equal to 5. For the case of A, for example, we take example of A. For the case of A, opposite hypotenuse is equal to 5, then opposite side is equal to 4. It's the reason why we take 5 over 4. For the case of B, opposite side is equal to 3, then adjacent hypotenuse side is equal to 5, is this one. So for the case of C, the angle in C is known, is 90 degrees. When we take secant is inverse of cosine, you know hypotenuse over adjacent side. For A, hypotenuse is equal to 5, adjacent side is equal to 3. For B, adjacent side is equal to you have hypotenuse is equal to 5 over adjacent side is equal to 4. Then for the point of C, we have hypotenuse is equal to 5, but there is no adjacent side with respect to C. Adjacent side is equal to 0. Can be not this one, can be not this one. As on this point, tangent, inverse of a tangent, you know tangent. When we inverse a tangent, it is like to calculate adjacent side over opposite side. Adjacent side over opposite side is inverse of tangent, or the value of cotangent. So it's calculated as here you see. A positive angle, example 12. A positive angle theta is in the second quadrant if cosine theta is equal to negative 3 over 4. Find the value of other primary trigonometric value. Means we have the first one cosine. We remain to find sine and we have to find the value of sine and the tangent. So when we draw our cycle, we make position first quadrant, second quadrant, fourth quadrant. This position cosine, let h, x, y be hypotenuse, adjacent and opposite side. This is hypotenuse, this is adjacent, this is opposite side. Then consider cosine theta is equal to negative 3 over 4 as here you have. Then x over h from formula as cosine is equal to adjacent side over hypotenuse is equal to 3 over 4. So adjacent, this adjacent side is in negative direction. X is in second quadrant, means in negative direction, means x will be equal to negative 3, then h is equal to 4. Then as h is greater than 0, we get this value from Pythagorean theorem. We know a triangle. We have a triangle where hypotenuse is equal to h. We have h square is equal to adjacent side square plus opposite side square. We have a value of h and the value of x. We remain to find the value of y, or opposite side. Opposite side is up, considering a cycle. Then after calculating this value, y is equal to plus or minus square root of 7. We consider the positive value. We consider positive value because in the second quadrant, x is negative, but y is positive. As when we draw, x is positive and y is x is negative, y is positive. The reason why we take the value of y, which positive. Finally, we calculate cosine sine of x is equal to square root of 7 over 4 as the opposite side of a hypotenuse, and the tangent of theta is equal to opposite side is equal to it is opposite side over adjacent side, which is equal to negative 7 over 3. Trigonometric number of special angles means we have 34, 45, and 60 degrees. When we consider a triangle where we have adjacent side, well, this side is equal to 1, this is equal to 1, and from Pythagorean theorem, here we get square root of 2. So to find the value of this degree, the degree, as here we have 90 degrees. This length is 1, and the second length is equal to 1. The angle of this one is 45 degrees, as here you have 45 degrees. Then hypotenuse is equal to square root of 2. So by calculating sine of this angle of 45 degrees is equal to opposite side 1 over hypotenuse square root of 2 is equal to this one. When we make some rationalization, we get square root of 2 over 2. When we calculate cosine of this angle is adjacent side over hypotenuse, meaning is equal to 1 over square root of 2. So also will be equal to square root of 2 over 2. Cosine of 45 is equal to sine of 45. Tan of 45 is equal to 1, means it is opposite side over adjacent side, means is equal to 1 over 1, which is equal to 1. We have another remarkable angles like 60 and 30 degrees. 60 and 30 degrees, here we have 90 degrees. This is 90 degrees. Here you have 60 degrees. Here we have 30 degrees. Here you have 2. So cosine of this angle, here we have square root of 3. This side you have cosine of 3. You have square root of 3, means cosine of 60 and sine of 60 here. Start from sine of 60 degrees is equal to opposite side is equal to square root of 3 over hypotenuse is equal to 2. As you consider sine of this side, sine of this side is equal to opposite side. This is 30 degrees. Sine of 30 degrees is equal to sine of 30 degrees is equal to 1 over 2. It is equal to opposite side over 2, as here it is 1 over 2. Then the tangent of this angle, is equal to opposite side square root of 3 over adjacent side, which is equal to 1, means is equal to square root of 3. As the tangent of 30 degrees, also consider this one. We have opposite side over adjacent side, means it is equal to 1 over square root of 3. So from this relation, we can also calculate the value of 0 degrees. Sine of 0 is equal to 0, cosine of 0 is equal to 1, and so on, as here you see 360 degrees. We have trigonometric identity from Pythagorean theorem in unity triangle where radius is equal to 1. That unit triangle gives this relation. Cosine square of theta plus sine square of theta is equal to 1. This is fundamental of trigonometry. From this relation, we can derive another relations. When we take this relation, we divide it in two sides by cosine square. For example, we get 1 plus tan square theta plus secant square of x. When we divide this first, second, and second side by sine square, we get 1 plus cotan square of theta, which is equal to cosecant square of theta. We have an example here. We can make simplification with cosecant x over secant of x. We replace cosecant by its value 1 over sine, and secant its value with 1 over cosine. When we make inverse multiplication, we take numerator, we multiply inverse of denominator, we get the cosine of x over sine of x, which is equal to cotan of x. We have example 14. Example 14 is to simplify this relation 1 over tangent of x plus 1 over cotangent of x multiplied by sine x cosine x. We have to write this relation 1 over tangent and 1 over cotangent in the function of sine and cosine. Then we write inverse of this one is cosine of x over sine of x, sine of x over cosine of x. We put it in a common denominator. We write cosine square. We write cosine of x, cosine x. It is cosine square. Sine x is sine square. We make simplification of this one and this. We remain with this relation. After getting this relation, we can write cosine square of x plus sine square of x. This is fundamental formula of trigonometry. This fundamental formula of trigonometry is equal to 1. This is the end.